we're going to learn something about, it's called a sequence. S-E-Q-U-E-N, sequence. Okay, sequences. What is a sequence? Sequence is the whole series of numbers. For example, 1, 2, 3, 3, 5. It's like this, and that's called a sequence. And we call this AN. We use this symbol to show that's a sequence. And here n can be 1, 2, 3, 4, 5, the natural numbers. Therefore, in this we should have A1, A2. That's a first term. We call this term. First term, second term, third term, and so on. Okay, so for this sequence we have over here, and A1 is 1, A2 is 2, A3 is 3, and A4 is 3, A5 is 3, and A6 is 5, and so on. So you can tell the sequence is just like the whole series of numbers, and then we use comma putting between them, and that also it has the order. The order makes sense, right? It's order. It's the first one, second one, third. We call this first term, second term, third term. If we have a finite number, for example, finite number of numbers. For example, I have 2, 5, 8, 10. Okay, this one we call this finite sequence. Finite sequence, you have a limited number of numbers. And this one, if I put 1, 2, 3, 3, 3, 5, comma, and I have all those dots, it keeps going forever non-stop. And this one, we're going to call that infinite sequence. So it's very obvious, either finite or this one is called infinite. So that's the two type of sequences. Depends on whether there's a limited number of terms or there are many infinitive numbers of numbers in the sequence. Okay, so that's the two type. And to show this AN, or to use a formula to show AN, there are two ways to do it. The first one is the two ways to show it. The first one, I give you the equation or the formula. For example, I have AN equals 2n plus 3. And remember, now you are so good at a substitution, right? You're so good at substitution. So for A1, okay, which is here, you're going to substitute this n with 1. So you have A1 equals 2 times 1 plus 3. Okay, so that is 5. All right, and A2 is A2. Here's 2, n equals 2, A2, and substitute this n by 2. So that's going to be 2 times 2 plus 3, which is 4 plus 3. We get 7, right? So I can continue. I get A3. In this case, n equals 3. So that will be 2 times 3 plus 3. 2 plus 3, 6, plus 3, 9. I can use this formula and continue. I can get all the terms. So this is one way I show you the formula, and you can write AN. Okay, so I give you the formula, and then you substitute n from 1, 2, 3, 4, 5, 6, 7. All right, so that's number one. Number two, the second method. The second way, we call this recursion formula. Recursion formula. What's that? Recursion formula, let me give you one example. AN equals 2AN minus 1 plus 5 for n greater than or equal to 2, and A1 usually is given. For example, we give you this one. A1 is 3. A1 is 3. And then when n is 2, and then 3, and 4, and 5 for the other terms, from the second term and the later, AN, which is the nth term, that is 2 times n minus 1, which is the previous term of n, right? So each term is 2 times the previous term plus 5. And then when n equals 2, here will be a2, and in this case n equals 2. So when here, if n equals 2, 2 minus 1 is 1, so a2 is 2a1 plus 5. Can you see that? a2 equals 2 times a1 plus 5. And a1, we already know that. a1 is a 3. So that will be 2 times 3 plus 5. That will be 11. Okay, so we have a1 is a 3, and a2 is 11. a2 is 11. a2 is 11. Yeah, and then we can go ahead, we can get a3. Okay, a3 is 2 times the previous term plus 5. So that will be 2 times a2 plus 5. We just had a2, so that will be 2 times 11 plus 5. That will be 22 plus 5. That will be 27. See, you have a3. Now we call this a recursion formula because I have to give you a 1, and then I give you the relationship between the n and n minus 1th term. So I give you the relationship between 2 consecutive terms. So from a1, you can use the formula to get a2. And then from a2, you can use the formula to get a3. It's not like this one. This one, you can calculate, for example, if n is 100, then you can just get a100, which is the 100th term. That will be 2 times 100 plus 3. That's 203. But for this one, it's not that obvious. In order to get a100, you have to figure out a99. In order to get a99, you have to get a98. Okay, so that's the big difference between these two ways to give you the sequence. Factorial. Okay. This factorial is this definition. First of all, 0 factorial is 1. This is by definition. There's no reason. Okay, don't ask me why. And 1 factorial is 1. 2 factorial is 2 times 1, which is 2. And 3 factorial is 3 times 2 times 1, that is 6. All right, now 4 factorial, which is 4 times 3 times 2 times 1, which is 4 times 3, 12 times 2, 24, plus 1 is still 24. Now, you see this pattern? So if I ask you, what is the n factorial? That will be n times, there will be n times 1 less than that, which is n minus 1, again, times n minus 2, times, all the way till you get a 3 and a 2 and a 1, you stop at a 1. So this is the factorial definition, and this one is just by definition, because in this case, you have, if it's 1 factorial and here is 1, you just start and then you stopped. So this, from 1 factorial, we just use this formula. But if it's 0, it has to go by definition. So 0 factorial is 1. Okay, so we have this general idea about what is the factorial. All right. Now, let me ask you this. Okay. Find the first 4 terms. I need to find A1, A2, A3, A4, right? That's the first 4 term of a sequence given you this expression, n plus 1, like that, okay? N plus 1 factorial. So let's work on A1. So let me just cross this. Okay, we work on A1. A1 equals, that will be 20 divided by, here A1, here will be 1. 1 plus 1, which is 2. 2 factorial, which is 2 times 1, which is 2. So A1 is 10. See? I get the term, right? So A2 is 20 divided by 2 plus 1 factorial. That is 20 divided by 3 by 2 by 1, and the answer is 10 over 3. Because you cross out this 1 doesn't count, so 2 and 20 cross out to get a 10. What about A3? I don't have space, so I just write here. A3 equals 20 over 3 plus 1, which is a 4 factorial, or 20 divided by 4 by 3 by 2 by 1. And a 4 cross out with 20, you get a 5 on top. And so the answer is 5 over 6. Can you find A4? A4 will be 20 divided by 4, n equals 4. So 4 plus 1 is 5. 5 factorial is 5 times 4 times 3 times 2 times 1. 5 factorial. And then 4 times 5 is 20, cross out with this 20, so answer is 1 over 6. So far we have A1 10, A2 10 over 3, A3 5 over 6, and A4 is 1 over 6. We get the first 4 terms. We're going to learn a new concept. It's called a summation notation. Summation notation. Okay, it's a Greek letter sigma, and we have a letter I equals, okay, from L to U. It just the numbers, and A I. Okay, when we read that, it will be the sum of AI, and this I call this as index. This is the little index of the ith term, right? So that's the index. And this L, I call this lower limit. And U, I call this upper limit. Okay, so I will have I from L to U, AI. What does this mean? How do we use it? I'll give you one example. Okay. I equals 1 to 5 AI. Okay, if I ask you to expand this, that will be I, which is this little I. I is from 1 to 5. So you can use your finger to count. That will be 1, 2, 3, 4, 5. From here to here, from 1 to 5. So 1, 2, 3, 4, 5. There are 5 terms. They are A1, A2, A3, A4, and A5. Okay, this is called expansion of this summation notation. How about I goes from 4 to 9 AI? Again, you have to count how many terms. I go from 4 to 9, so there will be 4, 5, 6, 7, 8, 9. So there's 6 terms. What are those 6 terms? They are A4, starting from the lower limit, and then every time just go up by 1. Okay, and A7, and A8, and A9. 1, 2, 3, 4, 5, 6. That's 6 terms. All right. Make sense? Okay, now let me give you one more example. Okay. How do you write K equals 3 to 5? And what I ask you to add, I ask you to add 2 to the K minus 3. Now, first of all, how many terms? K goes from this index, they use K, goes from 3 to 5. So 3, 4, 5. 3 terms. The first term will be just a plug in K equals 3. So there will be 2 to the 3rd minus 3. That's the first term, right? And then the second term, because K starting from 3 to 5, so the middle one is 4. So K will be 3 and 4 and 5. Now we plug in K equals 4. There will be 2 to the 4th minus 3. And the last one, we stopped at 5. So 2 to the 5th minus 3. Okay? So this is very, very clear that we're going to get the summation of this many terms, and K goes from 3 to 5. So 2 to the 3rd, which is 8. So that is 8 minus 3 and then 2 to the 4th is a 16 minus a 3, and then 2 to the 5th is a 32 minus a 3, and then you're going to go ahead and calculate this, and the answer is a 47. So that's how you figure this out. There's a very special, interesting question. Let me give you this. Okay, I equals 4 to 7 and 5. What does this mean? Okay, this is a very interesting question. That means you have some term. How many terms you're going to add? You're going to add from I equals 4 to 7. So there'll be 4, 5, 6, 7. So they should have 4 terms, right? You're going to add these 4 terms together. And what is each term? No matter what I is, each term is 5. So it's going to be 5 and a 5 and a 5 and a 5. You don't have to plug in. You don't have I to plug in somewhere. It's a constant. So when I equals 4, it's a 5. When I equals 5, it's a 5. When I equals 6, here's a 5. And when I equals 7, there's another 5. So the answer is 20. Okay, so you get the idea? So that shows you how to calculate this. This is interesting. So you always figure how many terms. Okay, what about this one? Just give you one more exercise. I goes from 1 to 4, and I square. Can you do this? That means I goes from 1 to 4, so I know I need to add 1, 2, 3, 4. I need to add a 1, 2, 3, 4. Okay, and for each term, I need to plug in I into this expression. So that will be 1 square, then 2 square, then 3 square, and a 4 square. So which is 1 plus 4 plus 9 plus 16. So the answer is 30. Okay, so this is everything about the sequence. Next, we're going to talk about one special sequence. We call this arithmetic sequence. Arithmetic. What is arithmetic sequence? It has another name, common difference sequence. For a common difference sequence, you can tell we have A1, A2, A3, and all the terms, and every term they have the same difference. So that's called an arithmetic sequence. For example, if I give you like a 5, 10, 15, 20, 25, and so on, this is very obvious. It's a common difference sequence, right? Because each time you just go up by 5. So 5 plus 5 you get 10, 10 plus 5 you get a 15, plus 5 you get 20, and plus 5 you get a 25. So what is the difference? What is the common difference? That's 5. The later term minus the earlier term. So they have a common difference, 5. So this is called arithmetic sequence. So the definition looks very obvious. Now let me give you this example. If I give you A1 is 100, and then I give you another formula, AN equals AN minus 1 minus 30 for n greater than or equal to 2. Okay, and I ask you to write the first 6 terms. I already have A1, so I'm looking for A2, A3, A4, A5, and A6. That's what I'm looking for. And we know this, we were told this is a common difference sequence. The common difference is AN is AN minus 1 minus 30. So every term is the previous term minus 30. So A1, then A2 will be here, n equals 2. 2 minus 1 is 1. So A2 is A1 minus 30. It's A1 minus 30, which is 100 minus 30. The answer is 70. Okay, then what about A3? We plug in 3 here, so A3 will be A2 minus 30. And that will be 70 minus 30, so you should have 40. And of course, A4 will be A3 minus 30, so that's 40 minus 30. The answer is 10. And the A5 is the previous term minus 30. The answer is negative 20. And A6 is the previous term minus 30. So the answer is negative 50. So far we have 1, 2, 3, 4, 5, 6. We get the first 6 term of this sequence. All right. So this is 1, 2, 3, 4, 5, 6. If I ask you to write the first 6 terms of this arithmetic sequence by giving this formula, you should be able to write it, and you can tell each time the difference is negative 30. So from 100 down by 30, down by 30, down by 30, down by 30, down by 30. Make sense? Yeah. If we know A1 and we know the common difference D, can we find A2? Yes, A2 will be A1 plus D. The common difference, right? Common difference is D. So for arithmetic sequence, A2 will be A1 plus D. What about A3? A3 will be A2 plus D. Common difference. A2 is A1 plus D, so this becomes A1 plus D, and that will be A1 plus 2D. Okay? A4 will be A3 plus D, so which is this thing plus D, so that will be A1 plus 3D. A5 will be A1 plus 4D, and A6 will be A1 plus 5D. Keep going. What can you tell? I can give you the formula. AN equals A1 plus, look, A5 is A1 plus 4D, not 5, 4. So it's a 5 minus 1. And that would be N minus 1. This many D. Okay. AN is A1 plus N minus 1, D. And for A1, if you take N equals 2, that will be A2 is A1 plus D. If you take N equals 3, so A3 will be A1 plus 2D. So every time from A1, you add a D, add a D, add a D, add a D. So this is the most important formula for arithmetic sequence. All right. Now, the good thing, if you look at this, A1, if A1 is given, in most of the case is given, and if I want to know which term I'm looking for, if I know D, can I find AN? Of course. Okay, so let me write the formula again. AN equals A1 plus N minus 1 D, right? Okay, now let me do this. If I give you A1, it's a 6, and the D is minus 5. What does that mean? That means go from 6 every time you go down by 5. Every time you go down by 5. And I'm asking, what is A9? Okay. What is this? A9. This 9 is actually N. So do we know N? Yes, N is 9. So we can just easily plug into this formula. So we have A9 equals A1 plus N is 9, don't forget. So that will be 9 minus 1 times D, right? And we know A1. That's 6 plus, here's 8. D is given, negative 5. Therefore, I have a negative 40 plus D. I have a negative 34. All right. So I have the 9th term. The good thing I have this formula is I don't have to go from A1 to A2 to A3 to A4. I don't have to do that many work. I can just plug in N and a D, and then I can find AN. Right. And also, for this N, right now, N is 9, which is a fairly small number. But if I ask you what is an A100, I guarantee you don't want to do that. Right. For N equals 9, we can probably try. We can get a 6. That's the first term. Second term, minus 5. 6 minus 5, it's 1. And then minus 5, right? And then negative 4 minus 5, that will be negative 9. Negative 9 minus 5, negative 14. And then minus 5, negative 19. Minus 5, negative 24. Okay, minus 5 again, negative 29. How many terms do we have? 1, 2, 3, 4, 5, 6, 7, 8. Last one, number 9, negative 34. See, if n is not a very big number, you can even do this. But to plug in the formula will be much, much easier. Next, we're going to work on the sum. We'll find the formula of the sum of arithmetic sequence. So S n, which is I equals 1 to n, so you know there are n terms, and ai. And this one, this ai, is arithmetic sequence. So let me give you the formula, okay? Plus n over 2 times a1 plus an. Okay, what does this mean? That means if a1, a2, all the way to an, it's a finite arithmetic sequence, then the formula gives you the sum of the first n terms, a1, a2, a3, plus them up, so a1 plus a2 plus a3. And then this formula, what tells you is, I don't really need to know all the middle terms. As long as I know the first term and the last term, and I know how many terms, I can find the sum. This formula looks very, very similar to when you calculate the area of this. If you have, this is a1, this is an, and there are n terms. See, that looks like that. If you want to get the area, is that the 2 base a1 plus an times n divided by 2. Okay, someone used this one to remember this formula. So let me give you one example. I want to ask you to figure out Sn of the first, that's the first n terms. First n terms of arithmetic sequence. That I give you the first term is a 6. a1 is 6. And I give you d is negative 5. I ask you to find S9. Can you do that? When I ask you to find S9, which means n here is 9, and then I can use this formula. However, I know n is 9, this is 9 over 2, so I know 9 over 2. a1 is given. What about an? I don't have an, but I do have the formula earlier. an is a1 plus n minus 1d. See, you have to use this formula to get an, which is a1 6 plus, we're looking for a9. So there will be 9 minus 1 times minus 5. If you remember the number, this is 8 times negative 5, negative 40. We just did that. And then plus that, we get a negative 34. See, I have a9. So S9 is this. It's 9 over 2 times a1 is a 6. And a9 is negative 34. And 6 minus 34 is negative 28. Negative 28 divided by 2, I have negative 14, and times 9, the answer is negative 126. So we find out the sum of the arithmetic sequence. So this is a very important formula, and this is a very important formula for the arithmetic sequence. Okay, once you know this, then you can solve most of the arithmetic sequence problem. Next topic we're going to talk about is another kind of a sequence is called a geometric. Geometric sequence also have a nickname. The nickname is a common ratio sequence. And here, sorry, this is common ratio sequence. Okay, common ratio sequence. The earlier, the arithmetic is a common difference. So from A1, we add a number, D, and then we add another number, D, we add another number. So we get the sequence, we get the whole series of numbers, right? So we get A1, and then A1 plus D, we get A2, A2 plus D, we get A3, and so on. But this one is common ratio, and which means if you have A1, and then the next term will be A1 times R. Instead of a plus, we multiply by R. And then the next one will be this number times R again. So it's going to be A1 times R squared, and then A1 times R to the third cube, and A1 times R to the fourth, etc. So this one is called a geometric sequence. And if you want to use the formula to show that, will be AN equals A1 times R, which is the common ratio of the power is first term, second term, third term, so it's going to be the n minus 1. Nth term, the power is n minus 1. So this is for n is greater than or equal to 2. Okay, so this is the geometric sequence. If I give you one example, it will be like this. Example, the first term A1 is 5 and R is negative 3. Can you write the first 5 terms? Yeah. The first term is 5. The second term will be 5 times negative 3, which is negative 15. And the A3 will be 5 times negative 3 times a negative 3, right? So it's just this number multiplied by negative 3 again. That's why it's called a common ratio. And so that will be positive 45. Okay? All right. Then the next number, A4, will be 5 times, or you can say 45 times negative 3, which is negative 135. See, that's the first term, second term, third, fourth. I can do one more. A5 will be negative 135 times negative 3. The answer is 405. So that's the first 5 terms of this common ratio sequence or geometric sequence. Okay, so it's just how you write it. You can write here. A1 is 5, A2 is 5 times R, which is negative 3, you find it, and A3 can be 5 times negative 3 squared, and then A4 will be 5 times negative 3 cubed, because it's this guy times negative 3 again, right? So A5 is 5 times negative 3 to the fourth. Okay, so this is the example about a geometric sequence. So it's very similar. We have the formula for AN. Let me just repeat it. AN is A1 times R n minus 1. Okay, and of course you know what would be the next. We need to find the summation. Okay, now for summation, we have to think about the two things. The first one, if n is a finite number, then Sn, okay, Sn is Sn is A1 plus A2 and then all the way to An. So it's a limited number. So here is the formula. Sn will be A1 times 1 minus R to the nth power over 1 minus R. When n is a finite number, use this formula because you have an n, you have a limited number of n. Now, if n is infinity, that's a huge number, and then if absolute value of r is less than 1, for example, r is 1/2, which means every time you have to multiply by 1/2, so the number gets smaller and smaller. I mean, the absolute value gets smaller and smaller. In this case, as I can write as n, or I can just write as, because that goes forever. Okay, so if r is less than r's absolute value is less than 1, and to the nth power, this n is a huge number. So any number whose absolute value is less than 1, you multiply by itself many times. So this one will approach to 0. So 1 minus 0, that approach to 1. So this part will becomes 1. So the answer, it will be a1 minus 1 minus r, a1 over 1 minus r. But if the absolute value of r is greater than or equal to 1, then S, write this, is not a fixed number. In this course, we cannot do it. Okay, now you see this for the geometric sequence to calculate the sum, and there are 3 situations. The first one, we have to look at whether it's a finite number. So we look at Sn, which is this, or if n goes to infinity, which is an infinite sequence, and then we have to look at the absolute value of r. If that absolute value of r is less than 1, we use this formula. If the absolute value of r is greater than 1, then we cannot do it. We just say S is not a fixed number, and that'll be good. All right, so let's work on one example. 2 examples. All right. The first one, okay, I give you a1 equals 2, and I give you r equals -3, and I give you n is 9, and I ask for what is S of 9. Hey, you know that we try to find the sum of the first 9 terms of that. What is the first 9 terms of that? The first term, actually, if you want, you can do that. So you have a1 is 2, so what about a2? Every time multiply the previous term, multiply by -3, get the next term. So that will be this times -3, and a3 will be this times -3. I get a positive 18, and is that right? So a4 is this times -3. I have a -54. See, common ratio, right? So a5, this times -3, I get 162. And a6 times -3 again, I get a -486. a7, this times -3, and a8 and a9. So you can find all the numbers. They're big, I just don't want to do that. And you can add up, you can get S9. You just add them up, you get S9. Or I can use the formula S of 9 equals this is a1, and here is 1 minus r to the n over 1 minus r. We plug in, we know everything. We know a1. a1 is 2 times 1 minus r is -3, and n is 9, and the denominator is 1 minus -3, right? Okay, so what is -3 to the 9th power? That's going to be 1 minus, let's calculate this. -3 to the 9th power, you can use calculator to do that. It's going to be 3 times 3 times 3, and that's 9 times. And I can tell you the answer. It's 19683. And it's positive because -9 times, this is in odd number, so it has to be negative. Then negative becomes positive, and the denominator is 1 minus -3. I get a 4, and then if you use calculator to do this, you can get a 9842. Okay, so of course you're going to add all the first 9 terms. If you really like to calculate that, you add them up, you should get the same answer. See, this is a very interesting formula, isn't it? Okay, so this is for the finite r. Let me ask you another one. Give you one example. Okay. What about a1 is 3, r is 2/3. Can you find S? All right. a1 is a 3. What's the next term? 3. What's the next term? 3 times 2/3. That's 2. And then 2 times 2/3. It's 4/3. and then times 2/3 again. I get 8 over 9, and so on, right? I keep adding them. I keep getting them. Then I add them together. That'll be S. So first of all, they didn't give you an n, so this is an infinite sequence, and so it's infinite. Okay, that's number one. Number two, the absolute value of r. R is 2/3, so that's 2/3. That is less than 1. So yes, we can use the formula. The formula is this: S equals A1 over 1 minus R. That's it. So let's see. A1 is a 3, and R is 2/3, so that's going to be 1 minus 2/3. And 1 minus 2/3 is 1/3. So 3 divided by 1 over 3, which is the 3 times 3 over 1, right? Times the flip of it. So the answer is 9. That's your answer. All right. Let me give you another very interesting example. I always think this is very, very interesting. So let me ask you to find the sum one half plus 1/4 plus 1/8 plus 1/16 plus da 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 forever. Can you do this? And this is 1/2, then 1/4, 1/8, 1/16. You can tell this is a geometric sequence. This is A1, that's 1/2. And what is R? What is R? What is R? This one times R to get this. 1/2 times R to get 1/4. 1/4 times R to get 1/8. And that R is just the 1/2, isn't it? So it's A1 1/2, then times 1/2 you get a 1/4. 1/4 times 1/2 you get a 1/8. So we're looking for the S. Okay? By the formula S is A1 over 1 minus R. A1 is 1/2. And 1 minus R, R is 1/2. Again, this is infinite, and R has absolute value less than 1. So that is 1/2 over 1/2, and that is 1. All right. Now, I like to use a picture to show this concept. I think this is very interesting. Okay, this is a perfect square that has the side length of 1, and the first 1/2 is this area, because the whole thing has the area 1, right? So this is 1/2. And the second term, 1/4, isn't it? And then half again, 1/8, plus half of that, 1/16, plus half of that, plus half, plus, and you keep going and going, so until you're really, really close to this corner, you know, the little corner, very, very small area we don't count because that keeps going, and then so that add up to 1. That's this one. 1/2 times 1/4 plus 1/8 plus 16, right? That's 1. So that's a very interesting. I think this is fascinating. So far we did the sequence, and we learned the arithmetic sequence, and also we learned the geometric sequence.